which means there's a car at that pump, then the driver will not enter the gas station. Okay, then from there, let's first identify the mu and the lambda, because I have a feeling I think that is why I missed it on the other side. So we are told that the cars arrive according to a Poisson process of 40 cars per minute. My lambda is 40. Then each car takes an exponential amount of time for service with an average of 4 minutes. Okay, so again from here, it looks like for all the 4 servers, okay, so let's call them server 1, 2, 3, and 4. The time that they take to serve, all those times are independent and identically distributed. So we are not told they have different times. We're just told that the time it takes for a car to be served, the average will be 4 minutes. Okay, so 1 over mu, which is the average time each one of them takes, is 4 minutes. So I want to convert that to hours so that it can go hand in hand with this lambda, because I've already been told it's 40 cars per hour. So my 1 over mu is the one that is, we're told the average is 4. So that will be 4 over 60, which tells me that that is 1 over 15th of an hour. Okay? Because if I work with the minutes and the hours, then I will end up with very distorted information. They need to have the same unit time. So if it is per hour, then 1 over 15 automatically tells me that my mu is equals to 15. Okay, so let me keep my information there. My mu is equals to 15. Even before I try and understand the questions that I'm being asked. So again, it means that for us to just have an idea of the system that we're working with. So we have 0, 1, 2, 3, 4, 5, and 6, because that is our capacity. All this, the rates here will be equals to 40. And then if you have 1 individual, then this rate will simply be 15, because it's 1 of the 4 servers. So we're told 4 workers who will have served you, so that the system goes back to no car in the gas station. If there are 2 cars in the gas station and 1 exits, again, it will be that there are 2 workers who are serving this person, who are serving the 2 vehicles, and then 1 has finished. So the one with the smaller time, the rate there now will be 30, because it will be 15 plus 15. If there are 3 cars, then for 1 to exit means it is 3 of the workers, 1 of them has finished. The minimum of the smallest time of those 3 people who are serving, that will be exponentially distributed with a rate of 45, because it's 15 plus 15 plus 15. Then if there are 4 cars, it means all the 4 workers are busy. For 1 car to exit the system means that time that it takes is exponentially distributed, and the rate will be the rate of the time of each of those 4 workers, because we're looking at the smallest of those 4 times, and that will happen with a rate of 60, because that's 15 times 4. For it to move from 5 to 4, the rate will still be 60, because it's based on the 4 workers. And finally, even here, the rate is simply going to be equals to 60. Once we have understood the system in that format, then it now becomes very easy for us to go back to the questions that we are being asked. So we are told to assume that a driver is in a hurry, so that he will enter the gas station if and only if he will be served immediately. So for him to be served immediately, it means that there has to be a server, at least one of the servers is free. So if we were to answer the question, what is the probability that he'll enter the gas station? He can only enter the gas station if there is no vehicle, so it's the first vehicle, which means he will get a server, because all the 4 workers will not be busy to provide service. He can enter the gas station if there's one car, because at least there will be 3 servers who are idle, so he will get somebody to serve him. He can also enter the system if there are 2 cars, because if there are 2 cars, then at least there are 2 workers who can be able to attend to him. One of the 2 workers can be able to attend to him. He can also enter the system if there are 3 cars, so that he becomes the 4th car, because there will be 1 server who can be able to attend to him. If there are 4 cars in the system, then because he's in a hurry, he will not be served immediately, so he exits. So the probability that he will enter the gas station will be equals to, okay, so to answer the first part is the probability that there's no vehicle, so that he can now come in, because there are 4 workers, like I said, who are idle, can serve him. If there's 1 vehicle, he can still be able to enter. If there are 2 vehicles, he'll still be able to enter. Or if there are 3 vehicles, because now he can become the 4th vehicle. Okay? So that is what will help us to answer that question, because we are told he's in a hurry, he'll only enter the gas station if he's able to get the service immediately. So I repeat, if there are 4 cars, the probability of there being 4 cars means this person will not be attended to. They have to wait, because now all the 4 servers will be busy. So to get those probabilities, now we come back again. We still have our formula. So to get P1 now, it will be 40 over 15 times P0. So you can simplify that if you want to. So that is the same as 8 over 3. I divide through by 5. P2 will now be 40 times. So what will give us the P2 is this 40 times 40, and then this 15 times 30. Okay, so that's another way you can pick out. So that is lambda squared, and then you have your mu1, which is 15, and your mu2, which is 30. So again, if I simplify that, so this came to 8 over 3. If I simplify that, it's over 3 times P0. Then probability that there are 3 individuals in the system, 3 vehicles in the system. That would be your 40 times 40 times 40. And then the exit rate will be 15 times 30 times 45. Okay. Again, so this is what I would call mu1. This would be my mu2. That is my mu3. That is mu4. That is 5. And then that is my mu6. Okay, so if you were to label them, that's the way you would have it. So again, if I simplify that, the first one was 8 over 3. That became 4 over 3. If I simplify that, means I divide through by 5. That becomes 8 over 9. So 8 times 8, that is 64. 64 times 4 gives me 256. That divided by 81. I hope that is correct. And then even this, I could have simplified that to just be 32 over 9 times P0. Then my P4. So again, and I'll just borrow some of this information out here. So that will be 40 times 40 times 40 times 40. And then below here we have 15 times 30 times 45, then times 60 P0. So it means then that to simplify that expression, like I said, this is what we have simplified here. So I can just borrow that. And then 40 over 60 is 2 over 3. So I have 256 over 81 times 2 over 3, which gives me 512 over 243 times P naught. All right, P5. So again, for P5 now, it is this that we had, and then we're just multiplying again by my 60 times 40. So that will be your 40 to power 5, and then like I've said, this will be 15 times 30 times 45. Then I have a 60, and I have another 60. Let me do this so that you're not, so that I don't again make too many assumptions. So let me just write all of them down. Though that is what I was trying to avoid, but then again it helps me to explain something. So again, from here, all this is what we have found here. This is 2 over 3. So it means that I can simplify that now to have 512 over 243. Again, that is multiplied by 2 over 3 P naught. And eventually, again, quite a process. Eventually, for the last one, because I think I saw like we have some other questions, maybe one more. Okay, so that eventually now for my P6, hopefully you're able to see that pattern. My P6 would actually now simply be equals to what I have found here. So that will be, so 512 times, so that will be 1024. Then 243 times 3, that would give me 729. And then I multiply that by 2 over 3 times my P naught. So now eventually I know that when I sum all those probabilities from n is equals to 0 to 6, that is what is going to give me 1. Okay, so it means I'll add up all those probabilities. So the first one is simply P naught. P1 we found it to be, so now I go back to all my expressions. So I have 8 over 3 times P naught. My P2 was, did I get that right? Yeah, 32 over 9. P naught, please make sure we are not making a mistake anywhere. P3 is 256 over 81 times P naught. P4, we have found that to be, 512 over 243 times P naught. Then P5 was 10, 24 over 7, 29. And the last one, which is our P6, now turns out to be 2048, where I multiply 1024 by 2, and then 729 times 3, that gives me
2187.
Okay. 87 P naught. All that should be equals to 1. So try and simplify that and give me the value for P naught, please. Add up all those values. You can get a common denominator for all of them, which I think the easiest will be that 2187 seems to multiply across for all of them. So the first one would be, if that's the easiest way to work it out, I don't know. Okay, please get a simplification of that expression.
0.067.
Oops, sorry. To the gas tank. So you're getting P naught to be equals to
0.067.
0.067, like that, huh? All
Yeah.
right. So to answer the first part of the question, we wanted P naught plus P1 plus P2 plus P3. So this is 0.067. Then it means that P1 now becomes 8/3 times that gives us what? For P1. So substitute 8/3 times 0.067.
Pardon?
P1 is equals to? What is 8/3 times 0.067? That's what you're trying to get.
0.178.
Okay, we can round off to 2 decimal points. Okay, so 0.178. P2, 32.
Okay, it's 0.0. 0.178.
178, okay. P2, 32/9 times 0.067.
0.2.
0.238.
38.
Okay. Then finally P3, which is this 256/81 times P naught.
0.211.
0.211.
212.
Okay, somebody says 212.
Sorry, yes, 212.
All right. So if we add up all those probabilities, what do we get? Do the sum of those 4 probabilities.
Zero point six.
0.695.
695. All right. So that gives us the probability now that that this driver is going to enter the gas station, because that is the only likelihood of him finding a server who is free so that he will be served immediately. Then we are asked on average how long a car will have to wait for service. So how long does a car have to wait for service? It can only wait for service if there are, so that one is not too difficult for us to do. So for us to get the average waiting time, so that will be the average number in the queue, and then we're going to have our average arrival time. So starting with the ones that will be the queue, you're only going to be in the queue if there are 5 or 6 vehicles, because our number of servers are 4. So C plus 1 means that is 5 to 6, and then you have your n minus 4 times that probability, which means that when n is equals to 5, that will be 1 times the probability that there are 5 vehicles in the gas station. And then when n is equals to 6, that will be 2 times that probability. Okay? So probability P5, we didn't calculate that, but now we can calculate it. So it is 1024 divided by 729 times 0.067.
Zero 0.094.
0.094. Okay. Then 2 times the probability that there are 6 vehicles, which is 1048 divided by 2184. And then times 0.067.
0.0627.
0.0
627.
6 3.
627. 663, yes.
Okay. All right. So again, solve for that and tell me what you get as the average number that are waiting in the queue. And remember, an average number, even though we're talking about number of cars, you can still have fractions. So that will be equals to
0.22.
0.22. All right. Then to get the average arrival time, like we said, this will now be equals to our lambda, which is 40, then times those probabilities where we are saying this is from n is equals to 0 up to 5, because you can only enter into the gas station if there are 5 vehicles, so that you become the 6th vehicle, which will now be equals to 40 into 1 minus that probability that there are 6 vehicles in the car, which is this probability. So it means that is 40 times 1 minus 0.063, which gives us what?
37.4.
37 point?
48.
37.48. All right. So it means then that that average waiting time that we are talking about now will be the average waiting time will be your 0.22 divided by 37.4, which gives us what? 37.48. And that will be in terms of hours.
Okay.
0.22 divided by 37.48 is equals to
0.0058.
0058.
587.
Okay. Or we can even say that is approximately 0.006 hours. Yeah. Right? So that will be the average time. So again, if you cannot relate to that, then you can convert that to minutes. But that is the average time that they will wait before they get service. So I'm using hours because remember we converted everything to hours. Okay. So that is how you'd have gotten the second part of the question.